capacitor and inductor with respect to frequency. So if I consider a series RLC circuit, okay, which is being supplied by using a voltage source, this voltage source is can give the AC signals also. Okay, the total impedance of this circuit, okay, will be equal to R plus J into XL minus XC. The term units will be ohms. Okay, here the R is resistance, XL is the inductive reactance, X is the capacitive reactance. Okay, so R, the resistance value R will not vary with respect to frequency, but there are two terms which are XCL and XC, which will vary with respect to frequency. Let's see how they will vary. So X is equal to 1 by 2 pi Fc, XL is equal to 2 pi Fi. That means Xc will be inversely proportional to frequency. That means if frequency increases, that means input signal frequency increases, Xc will decrease. The same way, XL is directly proportional to frequency. That means if input frequency increases, XL will increase, vice versa. Okay. In the same way, let's see the capacitor behavior at two extreme points. That means F is equal to 0, then Xc will act as an infinity. Okay, so you substitute F is equal to 0 here in this formula, then you will get X is equal to infinity. And if you know, if you want to know some basics, if you have 1 by 0, then it will be infinity. If 1 by infinity, this will be 0 mathematically. The same way, if you substitute here, at frequency 0, Xc will be infinity. That means capacitor acts as a open circuit. In the same way, at F is equal to infinity, Xc is equal to 0, capacitor acts as a short circuit. Inductor behavior with respect to frequency. At frequency 0, XL is 0. That means inductor acts as a short circuit. At frequency infinity, XL will be infinity. That means inductor acts as an open circuit. Okay, we everyone knows that frequency 0 means a DC signal. That means you have a x-axis. That means x-axis means with respect to time, and this is a signal level y-axis. Okay, let's assume you have a 5-volt signal which will not vary with respect to time. This you can consider as a DC signal. Okay, then what is the frequency infinity where Xc will be short circuited and XL will be act as a open circuit? Okay, let's see. If you have a signal where there is a abrupt transition from t equal to t minus to, okay, t equal to t plus, that means the signal is constant till to some x1 value till t is equal to t minus, but at t is equal to t plus the signal suddenly jumps to some v2. Let's assume here you have v1 at t is equal to t minus, suddenly at t is equal to t plus signal jumps to v2. That means there is sudden transition at that between t minus to t plus, you can say the frequency of the signal is infinity. Okay, let's see what are the examples here. Okay, if you here are some of the examples for infinity frequency signal. So here if you see, this is a first one, the signal is varying from 0 to x1. So here I am saying voltage or current. That means the signal either might be generated by using the voltage source or by using a current source. Okay, so the signal here is going from 0 to x1, okay, level at very sharply, suddenly. That means the highlighted red area, this area has a frequency of infinity. In the same way, if you see here, the signal is going from 0 to x1. Here the transition, this point has an infinity frequency. In the same way, the signal is going from x1 to x2. This point has infinity frequency. If you see the third example here, the signal is going from 0 to minus x1 at this point. At this point, signal has a infinity frequency. Okay, so I think you have understood.